Welcome to Lecture 18, Unit 3. This is Mean, Variance, Standard Deviation, and Expectation. My name is Jorge, and this is for Statistics 2023. So the objective for this particular lesson is that we're going to learn how to find the mean, variance, standard deviation, and expected value for a discrete random variable. It's just a continuation from Lecture 17. So the way that we calculate these values are different than what we've done previously, such as group mean, variance, or just straight mean or variance. And so the formula for the mean of a probability distribution of a discrete probability distribution would be mu is equal to the summation of the product. So we take the first value of x times its probability plus the second value of x times its probability, and then add them all up. So the final formula is just the summation of x times p of x. And then x are the outcomes, and we already know that. And then p of x1, p of x2 would be the corresponding probabilities. So how do we find the mean of a number of spots that appear when a die is tossed? So we know that when we toss a die, we have 6 possible outcomes, 1, 2, 3, 4, 5, or 6. And the probability of each would be 1 over 6. So the expected value of doing this would be 3.5. And if you notice, what we do is we take the first value of x times its probability plus the second value of x times the probability all the way down to the last value of x times that probability, and then sum them all up and we get 3.5. So in a family of 2 children, find a mean of the number of children who will be boys. So the first thing is that the possible values would be 0 boys, 1 boy, or 2 boys. So that's the different values that x can take. So now the probability, using a tree diagram, we find out that it's 0.25 for 0 boys, 0.5 for 1 boy, or 0.25 for 2 boys. If we use the formula for the mean, we get that it's 1 boy. So if a family has 2 children, then the expectation is that one of those children will be boys. So here we have five coins to toss, find the mean number of heads that will occur. So the possibilities or the values of x would be 0, 1, 2, 3, 4, or 5. The probability of each one is listed. Again, we did this back in lecture 17. So using the formula, we find out that the mean is 2.5. The next thing we're going to talk about is variance and standard deviation. So here's the formula for variance. There are 2 formulas, but we get the same value. And then, of course, standard deviation is just the square root of the variance. And so I'm going to show you how to do that using Excel. So here, let's find the mean, variance, standard deviation, and number of spots that appear when a die is tossed. So the first thing that we're going to do then is, so we have our outcome x, and we have the probability for each one. So let's go to Excel and let's find the, so here we have, so find the mean, variance, and standard deviation spots that appear when a die is tossed. So spots with 1 die. So the expected value was 3.5, and we got that previously, right, when we just used the formula. Now, so the first thing that you do is you square your x's. So here's my x values, and here is the square of each one. Then what I do is I take my x squared times the probability of each one. So 1 times 0.1667, 4 times 0.1667, and then I sum those up. So now I have this row right here, which is the summation of the product of the x squares times the probability. So how do I get the variance? Well, the variance then becomes, here, if you notice, we go to G8. So the summation of this minus the mean squared, and then it'll be minus, so 3.5 is your C8, so we square that and we get the variance. And then the standard deviation is just a square root of the variance. So the variance for this particular example is 2.9, and the standard deviation is 1.7. All right, so let's go back to Excel here. So here we have another example. In a restaurant, the following probability was obtained for the number of items a person ordered for a large pizza. So the possibilities is 0, 1, 2, 3, 4, or 4 items. So the probability of each, so 0 items is 0.3, 1 item is 0.4, 2 is 0.2, 3 is 0.06, and 4 is 0.04. So what we're going to do then is we're going to find the mean, variance, and the standard deviation for this particular distribution. So going back to Excel, here's the restaurant. So the first thing that we're going to look at is, let me just make sure I got this in the middle, is the expected value. So the expectation is that people will order 1.14 items, right, for their pizza. So here are the different columns that you're going to have created when you do this in Excel. So again, I square my x's, and then I multiply, get a column with multiplication of the x squared times the probability of each. We sum those up. And then here, again, is the formula for the variance. So it would be 2.38 minus 1.14 squared, which gives me a variance of 1.08 and a standard deviation of 1.03. All right. So here's another example. So a talk radio station has 4 telephone lines. The probability that 0, 1, 2, 3, or 4 people will be placed on hold when they call a radio talk show is shown in distribution. So we're going to find the mean, the variance, and the standard deviation, and then look at the question, should the station consider installing another phone line? So either no one's on hold, 1 person, 2, 3, or 4 people on hold, and the probability for each one. So going to Excel, we can go ahead and build this out and see what it looks like. So the expectation is that at any given time, there'll be 1.6 people on hold, right? And so again, here are the columns that we have. And so the variance would be 1.2. So looking at this, so should the radio station consider installing a phone line? Well, it really doesn't look like they need another phone line, because at any given time, they'll have less than 2 people on hold with a variance of 1.2 and a standard deviation of 1.1. So it's not like they have an expected amount of people on hold be 2 or 3 people at any given time. So expectation is also known as expected value, and expected value is used in various types of games of chance and insurance and other areas such as decision theory. So what we've found, the mean of this can also be called the expected value. So when I flip a coin, what is the expected number of heads to get? When I roll a die, what is the expected number of spots that will come out? And so the mean is also known as the expected value. Now, the expected value of a discrete random variable, again, is the summation of x times p of x. E of x is used for expected value. Now, the formula for the expected value is the same for the theoretical mean. So the expected value then again is, in essence, the theoretical mean of the probability distribution. In other words, E of x is equal to mu. So here we have an example. 1,000 tickets are sold at $1 each for a color TV that's valued at $350. What is the expected value if a person purchases 1 ticket? So we have, if they win, then they literally win $349. If they lose $1, right? So although it's valued at $350, you paid $1 to play, so it's actually $349. So the probability that you'll win is 1 out of 1,000. The probability that you lose is 999 out of 1,000. So the expected winnings from this particular game is actually negative 65 cents. So if you play this game, chances are that you'll end up losing 65 cents. So here's another example. A financial advisor suggests that his client select one of 2 types of bonds in which to invest $5,000. So bond X pays a return of 4%, default rate of 2%. Bond Y has a return of 2.5%, a default rate of 1%. So we're going to find the expected rate of return and decide which bond will be a better investment. So when the bond defaults, the investor loses all of the investment. So here we have bond X and Y, the return for each, the default rate for each one. So the first one is 5,000 times 0.04, that's 200. 5,000 times 0.025, that's 125. So the expected for bond X would be $96. The expected for bond Y would be $73.75. So then you are better off in the long run of going with bond X. And that's the end of lecture 18, unit 3. Thank you.